We're back with parabolas in section 3 of chapter 10, and we're going to look to graph a couple of parabolas that have the vertex at the origin, and then from there we'll go into problems where the vertex might be at a different point. So to graph a parabola with the vertex at the origin, one of the things that you want to do is you want to be able to look at it and see if it opens upward or downward, if it opens right or left. If the x is the squared variable, then it's going to open either upward or downward, and if the y is the squared variable, it's going to open to the right or to the left. And as you can see, I've got a couple of examples here where the x is squared and where the y is squared. So we'll have one example of each type. Now, to help determine how skinny or wide your parabola is going to open to the right, to the left, upward, downward, you would want to most likely plot some extra points. Now, I usually tell students to create a T-chart and find some points that way. But if you're just looking for the bare minimum, if you can determine a key line segment, which has got kind of a silly name, but it helps us to determine how wide it is. It's a line segment that goes through the focus and is perpendicular to the axis of symmetry. And the endpoints of this line segment are on the parabola, and here's the name, no jokes please, it is called the Lattice Rectum. Yeah, I know. The endpoints of the Lattice Rectum are 2 times the absolute value of lowercase letter p there. Remember, that's the distance from the vertex to the focus, to the right and to the left, or upward and downward from the focus. The length of this line segment, which we call the focal diameter, helps us to determine how wide or how skinny the parabola is, and it is equal to 4 times the absolute value of p, because we're going to go this distance to the right, to the left. That's just going to double this. We're going to have 4 of these. So we'll do an example here. X squared equals negative 8y. First we're going to identify the vertex. Well, these are all set up with the vertex at the origin, so the vertex is set up at 0, 0. And we're going to figure out the focus here. Now, because of the way this is written, this fits the form x squared equals 4py. So as you can see in this case, it's negative, so it's going to open downward, and p is going to be, well, 4p is going to equal negative 8, so p is going to equal negative 2. So the absolute value of p, of course, is 2. We're going to go define the focus. Since it opens downward, the focus is going to be in the interior of the parabola, so it's going to be down 2 units from the origin, so the focus is going to be at 0, negative 2. The directrix is going to be above the origin, 2 units above the origin, and be the line y equals 2, which we're going to answer down here in just a second. Now, we also want to find the focal diameter. That's this 4 times the absolute value of p. So 4 times the absolute value of p, the focal diameter is 4 times the absolute value of p, which would be 8. Alright, so that distance we're going to use there as well. So that's going to be like 4 to the right, 4 to the left. Now, we want to identify the endpoints of the lattice rectum, and then we're going to graph this. Now remember, our vertex is here, and it's going to open downward. Does it open skinny? Does it open wide? Well, the focus is right here. So what we're going to do is we're going to go 4 units to the right, 4 units to the left. That's going to be a distance of 8. Well, from this point here at 0, negative 2, 4 units to the right would be at 4, negative 2, and 4 units to the left would be at negative 4, negative 2. And those would be the endpoints of your lattice rectum there. So you can see it's going to go through those points. You can see it opens kind of wide here. See if I can get this to draw this halfway decent. Oh, my pen's starting to fail me. There we go. And of course you want the symmetry to the y-axis, because the y-axis here is your axis of symmetry. So as for the directrix, remember that's up here, p units up here. So the directrix is y equals 2. The axis of symmetry, I'll just abbreviate here, is the y-axis, or x equals 0. And these are the endpoints here. All right. Hopefully that one looks okay to you. Let's jump over here to this next one. Given y squared equals negative 12x, we're going to follow the same directions here. So this fits the form y squared equals 4px. So 4p would be negative 12. So p is equal to negative 3. So that means, remember, our vertex is at 0, 0 here. That means that we're going to, and notice here a negative number, so this is not going to open to the right but to the left. And our focus would be right here. Now notice my units here of 2. Would be right here at negative 3, 0, because it would be 3 units to the right. This would be the focus, but this is your vertex here. My directrix would be 3 units this way because of the absolute value of p, so it's going to be this vertical line here, which I'm going to sloppily sketch. So I'm going to need that down here anyway. What do we need? We need the vertex. Well, the vertex is the origin. And we need the focus. Well, that focus would be at negative 3, 0. And we need the focal diameter. Well, the focal diameter is 4 times the absolute value of p. So this is going to be 4 times the absolute value of negative 3, which is going to be 12. So the focal diameter, okay, the length is 12. So from the focus, I'm going to go 6 units up and 6 units down, and those would be the endpoints because it has to have length 12. This is 12 if I go 6 above and 6 below. This is the 2 endpoints of the lattice rectum, which would be at negative 3, 6 and at negative 3, negative 6. Okay. So now I just have to try to make a reasonable sketch. It's kind of a wide one as well. Oops. That's why you really need, to do this properly, you need more points than just the 3. I mean, those 3 give me a lot of information, the endpoints of the focal diameter and the vertex, but you probably should make a T-chart and plot a couple more just to make sure that you get a more accurate sketch. The equations of the directrix, I said was x equals 3, and the axis of symmetry, well, it's the x-axis, so that's y equals 0. Notice that your directrix and your axis of symmetry, for the ones that we're working on here, are all going to be horizontal and vertical lines, and of course, if one's vertical, the other one's horizontal, and so on. So what we probably need to do is expand this to go beyond just parabolas with the vertex at 0, 0. So that's coming up in one of the next videos.